Welcome all my dear students to Sudharma's Physics Classroom. Today we are going to discuss the let us assess part of the chapter for reflection of light from SSLC Physics. Already the chapter discussion is done. So hope all of you have read the chapter and very thorough with the mirror formula, magnification, what is the characteristics of the image, at different positions of the object for both concave and convex mirrors. Assuming that I'm moving on to the question discussion. So if you feel you are not thorough with that, it's important you have to learn it and come back and watch this video, because if you simply directly move on to the questions, I'm sure you will not understand anything, because you need the clear understanding of the chapter. So if you are watching this class for the first time, or if you are new to my channel, go back to the previous videos of the chapter. There is a separate playlist for SSLC English medium physics, and there's a separate playlist for this chapter also. So go to that, learn the whole chapter and come back, okay, so that you get maximum use of this let us assess part. Because here see, it's not like the other chapters. If you don't have the knowledge about the mirror formula and the characteristics of the image, it's not easy to understand. That's what I'm very clearly specifying it again, okay. So let's move on to the question. The first question is, a dental doctor uses a mirror. A dental doctor uses a mirror of focal length 8 centimeter. To see the teeth clearly, what should be the maximum distance between the teeth and the mirror? Justify your answer. Which type of mirror has been used by the doctor? So, in the discussion of concave mirror and convex mirror and its uses, we have learned that a dental user, a dental mirror, right? Dental doctor's mirror or a doctor's mirror, makeup mirror, shaving mirror, all these are concave mirrors, right? Concave mirrors. So, a student who learned that can directly answer this question. It's a very simple question. A dental doctor uses a mirror of focal length. Focal length is given as 8 centimeter. We know that concave mirror has a focal length of negative value, right? So focal length is minus 8 centimeter. To see the teeth clearly, what should be the maximum distance between the teeth and the mirror? So maximum distance. See, we can keep the object between 0 to 8 centimeter, right? So a value which is less than this 8 centimeter, the maximum possible value which is less than this 8 centimeter, right? Because if you keep the object at 8 centimeter, what happens? It will be forming, the image will be forming at infinity. But the doctor need to see the teeth clearly. He needs to see what is wrong with their teeth, right? So we need a magnified image, and it should be a virtual image within the mirror itself. If you are going to keep the teeth at 8 centimeter, what happens? The doctor won't be able to see the image, because the image is going to form at infinity, where it will be formed within our mouth, right? That's not possible. So you have to keep it between 0 and 8 centimeters. So maximum distance can be less than that 8 centimeters. The maximum possible value which is less than 8 centimeters. Then only he will be able to see a magnified image. Okay. So this is the object position where concave mirror forms a virtual magnified image. Hope it is clear for you. Next question. Imagine that a spherical mirror gives an image magnified 5 times at a distance 5 meters. Image magnified 5 times at a distance 5 meters. If so, determine whether the mirror is concave or convex. Definitely, the moment you see a magnified image, we have learned only two types of mirrors. One is concave and the other one is convex. So if you see a magnified image, those who learned clearly can say this answer quickly. A magnified image is formed only by a concave mirror. Again, a concave mirror, right? Can be given by a concave mirror only, because a convex mirror always forms a diminished image. Concave mirror forms two types of images. One is magnified real image and magnified virtual image. So let's see what kind of image it is. It's a magnified image. So it's a concave mirror. It forms magnified 5 times. That means magnification is given here. Magnification is 5. Now the question is whether it is real or virtual, right? Then only we can put the sign. It is formed, right? A spherical mirror gives an image. See, each and every word is important here. Then if you read it between the lines, you can understand what kind of mirror it is, or what kind of magnification it is, or what type of image it is. It is a real image because it gives an image. If it is a virtual image, it cannot give an image, right? It will be within the mirror. Okay. So magnification is -5 because it is a real image. And at a distance 5 meter, it is formed at a distance 5 meters. So we can write image distance is 5 meter. When it is a real image, it's going to be -5. We are supposed to find out the focal length. Okay. So to find focal length, we need object distance, right? Because our mirror formula is 1 by v plus 1 by u is equal to 1 by f. Okay. So v is given. So we have to find out u. How do we find out u? Focal length is not given. So, but we have a formula m is equal to minus v by u. Magnification is -5 is equal to minus of v. V is -5 divided by u. So here minus and minus cancels and 5 and 5 cancel. So we'll be getting object distance as -1. So we can understand this is correct because object distance should be a negative value. Okay. Now how we can calculate the focal length. 1 by f is equal to 1 by u plus 1 by v. 1 by u, 1 by u is -1 plus 1 by v is -5. So 1 by, so this is going to be -1 by 1 plus -1 by 5. 5 is going to be the LCM. So this is going to be -5 plus -1, that is going to be -6 divided by 5. So focal length is going to be -6 divided by 5. -5 divided by 6 because 1 by f is equal to 1 by f is -6 by 5. So f is equal to -5 divided by 6, or we will be getting -0.833 meters because everything is given in meters. So we get the focal length also in meters. So this is a concave mirror and we got our focal length as a negative value. So now we have to check whether it's a correct answer or not. How do we check that? Object focal length is 0.833. 2 times focal length is going to be somewhere 1.6 something, right? So object is between C and F, right? Between C, 0.8 and 1.6. Object distance is at 1 meter. So we will be getting the image beyond C. Beyond C means beyond 1.6. What is the image distance here? 5 meters. So it's beyond center of curvature. And it's going to be a real magnified image. All the characteristics are matching with our values. So the answer is correct. Okay. Now let's move on to the third question. A motorcyclist observes a car coming from behind with a magnification 1 by 6. If the actual distance between the car and the bike is 30 meter, calculate the radius of curvature of the mirror. It is a convex mirror. Why it is a convex mirror? Because it is a rear view mirror, right? A motorcyclist observes a car coming from behind with a magnification 1 by 6. So magnification m is equal to 1 by 6. It is positive because it is a convex mirror. It is a virtual image form. So magnification is plus. So if the actual distance between the car and the bike, so the object here is the car, right? So object distance is 30 meters. Object distance is always negative, -30 meter. We have to find the radius of curvature of the mirror. So we need focal length so that we can find out the radius of curvature. Again, we are following the same method. We have magnification is equal to -v divided by u. So magnification is 1 by 6. That is equal to -v divided by u. U is -30. So the negative sign cancels. So v is going to be 30 divided by 6. That is nothing but 5 meters. Now we have object distance and image distance. So 1 by f is equal to 1 by u plus 1 by v. 1 by u, 1 by -30 plus 1 by v, 1 by 5. So this is going to be -1 by 30 plus 1 by 5. 30 is going to be the LCM, minus 1 plus 6. That's going to be 5 by 30 or 1 by 6. 1 by f is equal to 1 by 6, or focal length f is equal to 6 meter. So the radius of curvature r is equal to 2 times f. 2 into 6, that's going to be 12 meters. Positive 12 meters because it's a convex mirror. Okay. Moving on to the fourth question. A shaving mirror. What type of mirror is a shaving mirror? Definitely, automatically it should come to your mind. Shaving mirror is a concave mirror. I didn't even read the complete question. Shaving mirror. The first thing I'm going to write here is concave mirror. Because based on that, I will have to put all the signs. Focal length 72 centimeter. Concave mirror focal length is negative. Is kept by in a beauty clinic. A man uses it standing 18 centimeter away from the mirror. Man uses, that means the object is the man. So object distance is always negative, minus 18 centimeter. At what distance will the image be formed? We have to find out the image distance. We have the mirror formula, 1 by f is equal to 1 by u plus 1 by v. So we have to find out 1 by v, right? 1 by v is equal to 1 by f minus 1 by u. So 1 by minus 72 minus 1 by minus 18. So 1 by v is equal to minus 1 by 72 plus 1 by 18. We have LCM of 72 and 18. It is 72. So 72, and here we have minus 1. Here we have 4, right? 4 18s, you get 72. So finally we will get it as 3 divided by 72. 3 by 72, or again we can cancel it, 1 by 24. So V is equal to 24 centimeter. I am getting V as a positive value. When we get the image distance as positive value, that shows that it is virtual. All the virtual images will be upright. Okay, upright or erect. Now, is the image real or virtual? We got the answer, it is a virtual image. What is the magnification of the image? Magnification m is equal to minus v divided by u. Minus of v is 24, u is minus 18. So minus and minus cancels, and we get the magnification as 1.33 plus 1.33. So it's matching now because it's virtual image. Virtual image magnification is going to be positive. And concave mirrors. Shaving mirror is a concave mirror. We get a virtual magnified image. So positive, and the value should be greater than 1. So our answer is correct. Moving on to the fifth question. Wrap a rubber ball of diameter 12 centimeter by completely with an aluminium foil and make the surface smooth. Where will be the image of an object kept 12 centimeter away from the center of the ball? Is the image real or virtual? Wrap a rubber ball of diameter 12 centimeter. So the rubber ball is of diameter 20 centimeter. We're going to wrap this ball with aluminium foil. So we know that the outer surface of this ball is going to be shiny, right? That is going to be the reflecting surface. So when we say diameter is 12 centimeter, radius is going to be 6 centimeter, right? So our mirror is going to be a convex mirror because the bulging surface, the reflecting surface is bulging outward. So that is going to be a convex surface. Okay. Now, object is kept at 12 centimeter away from, read the question carefully, 12 centimeter away from the center of the ball. From the center, it is kept at 12 centimeter. That means from the reflecting surface, this is going to be at 6 centimeter. This is our object. So what all data is given there? Radius of curvature is 6 centimeter. So focal length is going to be 3 centimeter. I am putting positive sign because it's going to be a convex mirror. Object distance is always negative. It is minus 6 centimeter because total distance from the center to the object is 12. So from the center till the mirror surface, it is 6. So from the mirror to the object, it is 6 centimeter. Okay. So we have object distance and focal length. We have the mirror formula, 1 by f is equal to 1 by u plus 1 by v. We are supposed to find out image distance. 1 by v is equal to 1 by f minus 1 by u. So 1 by f, 1 by 3 minus 1 by u is minus 6. So 1 by v is equal to 1 by 3 plus 1 by 6. 6 and 2 plus 1. So 3 by 6 or 1 by 2, or image distance v is equal to 2 centimeters. So we're getting the image distance positive. So this is going to be a virtual image. It's a virtual image. So this is how we apply the sign conventions and do the questions. Moving on to the sixth question, we are able to read the book since light falling on a surface gets reflected from the book and reaches the eye. Both, but on such occasions we cannot see our images like that from a mirror. Explain why. We are able to read a book since light falling on a surface gets reflected from the book reaches the eye. Definitely we are able to see the things because of reflection of light. But during that time, we cannot see our images like that from a mirror. See, mirror, it has a smooth surface. From a mirror, we know that a regular reflection takes place, right? What is the major difference here? If you consider a book, it has a lot of irregularities, right? It has a lot of irregularities. So if a beam of light, a parallel beam of light hits this mirror, hits the rough surface, the reflected rays will go randomly, right? It will not go parallel to each other. And there will not be a clear image formation. But in case of a regular reflection, the reflected rays also will be parallel to each other. Okay? So the reason is from a paper, from a piece of paper, we are getting a diffused image, right? A diffuse reflection is taking place and blurred image formed or no image is formed sometimes. Most of the time, no images will be formed during a diffuse reflection or irregular reflection of light. Okay. So moving on to the seventh question, it's a very interesting one. Is the image formed by a plane mirror real or virtual? What a question it is. Everyone knows it is a virtual image, right? Because in the first class itself, we have discussed about the characteristics of plane mirror image formation. It is a virtual image. Let's revise what are the properties. It's of same size, it's behind the mirror, it is equidistant, it is laterally inverted, etc., right? Now, they're asking, we know that a virtual image will be always upright, right? Hope you remember the ray diagram for a plane mirror. If I have an object like this, the image will be at equal distance from the mirror, but on the other side, but it will be the same as that of the object. We need an object, an image inverted using a plane mirror. How do we get an image in the inverted form from a plane mirror? As we know, it is a virtual image. Virtual images will be upright, right? Let's think. Let's think about any possibility where we can get an inverted image. See, they're asking only about an inverted image. They didn't ask us to form a real image using a plane mirror, right? So we need an inverted image. Let's see logically. See, if I have a plane mirror like this, if I stand on this mirror, what would be the image? Comes like this, right? It's an inverted image. That's it. So stand on the mirror, stand perpendicular to the mirror. See, it's not at a distance. See, in the first case, what happened is the mirror and the object, they are in different vertical planes, right? Here it is in a perpendicular plane. So we are standing on the plane mirror, so the image will be inverted. If you are doubt, if you have any doubt, you can try it. Take your pencil, keep it on the mirror, perpendicular to the mirror. Keep it perpendicular to the mirror. So you see an inverted image of your pencil within the mirror. Okay. So this is the possibility or an example or an instance where the plane mirror forms an inverted image. Definitely it is not a real image. No doubt at all, it's not at all a real image because of the position we are standing on that mirror, right, or the position of the object, the image looks inverted. It is a virtual image itself. It is not a real image. It's a virtual image, okay, but inverted. Okay, so that's all about the lattice assess part from the reflection of light. Now we have finished. We have completely done with part one of our textbook. Now we have to go to the second textbook, right? There we are going to discuss about another very interesting phenomena of light, refraction of light. Okay, because see, we are learning the different phenomena of light and we are trying to relate that with real life situations. Okay, so I'll be coming with a lot of interesting examples and experiments for the chapter refraction of light. If you are new to the channel, please subscribe to the channel and press the bell icon for more updates on the classes. Every week I'm putting 2 videos related to the chapter discussion, text back exercises, all those things are discussed in the classes. So don't miss that. Utilize it to the maximum. And I'll be coming with a refraction of light very soon in another video. So see you soon. Thank you for watching. Bye.